All right, so in 6-2, our topic is the trigonometric functions and period. Okay, so the first thing that we come into is kind of a quick discussion of domain and range for the sine and cosine functions. And so the domain for sine and cosine functions is the set of all real numbers. Because when you're looking at sine and cosine, okay, as far as values for t that you can put in for the input for the domain, remember, it can be positive numbers, it can be negative numbers, it can go all the way around, and that t would be 2 pi. But if you go around again, it's 4 pi. If you go around again, it's 6 pi, 8 pi, and so on. There's no limit to the number of times you can go around the circle. All right, so the value that you plug in for the domain can get as big as you want it to get, or as small as you want it, or as negative as you want it to get as well. All right, so there's no restrictions on the domain for what you can put in for the sine and cosine functions. However, when we start talking about the range, okay, think about this. Okay, because remember this point x comma y is on the unit circle, then you know that the y's got to be what? From -1 to 1, and the x has got to be -1 to 1, because remember when you look at the unit circle, all right, if the point you're using is a point on the unit circle, there's no way that the x value can be greater than 1, or it can't be less than -1. And then same thing for the y value, since it's going around in the circle. And so the range for the sine and the cosine functions is between -1 and 1. That's the range. Okay, so there's no limit for the domain, but the range has to be between -1 and 1. All right, so that's your range. So now we kind of start getting into a discussion about period. What does it mean for a function to be periodic? Okay, so remember, all the way around is 2 pi, right? So adding 2 pi to each value of t in this initial interval from 0 to 2 pi, that completes another revolution around the circle, right? So really, for the values of sine of t plus 2 pi, all right, and t plus 2 pi, all right, they correspond to sine of t and cosine of t, because wherever you're at, let's say we're here on the unit circle at this point. If you go 2 pi from here, you're all the way around the circle back at the same spot. Okay, so that means that sine of t and sine of t plus 2 pi is the same value. Same thing for cosine of t and cosine of t plus 2 pi. They're the same value. They match. All right. And so similar results can be obtained for repeated positive or negative revolutions around the circle. Right. So in other words, sine of t is the same as sine of t plus 2 pi. The same as sine of t plus 4 pi, plus 6 pi, plus 8 pi, and so on. And we kind of mentioned that a little bit earlier when we were talking about the domain. All right, and same thing, -2 pi, -4 pi, -6 pi, any multiples of 2 pi. So that results in this general equation. The sine of t plus 2 pi times n, whatever integer you want that to be, right, equals to the sine of t. Okay? And likewise, for cosine of t plus 2 pi times whatever integer. This integer n stands for however many times you're going around. If this is 1, you're going around the circle 1 more time. If it's 2, you're going around the circle 2 more times, 3, and so on. So anything in this form would be equal to sine of t, because you're just going round and round in the circle, right? So you would get the same value, all right? So, like I say, if you add 2 pi, that's 1 time around the circle. If you add 4 pi, that's 2 times. 6 pi, 3 times. 8 pi, 4 times, and so on. And you'll get the same value as what you got with sine of t. Okay, so for any integer n and real number t, so we talked about that. All right, so functions that behave in such a repetitive cyclic manner are called periodic functions. Periodic functions. All right, so sine and cosine are examples of periodic functions. All right, because they repeat the same values over and over. We got the formal definition of a periodic function here. A function f is periodic when there exists a number, a real number c, such that, have a good weekend, real number c such that f of t plus c equals f of t. And then that's what we've got as far fitting the definition for sine and cosine. For all t in the domain, the least number c for which f is periodic is called the period. So the least number c for which f is periodic is called the period. So the least number c for which sine and cosine are periodic, okay, would be, if this number was 1, so that would be 2 pi. So the period for sine and cosine would be 2 pi. And then that's what this statement says. So it follows from the definition that the sine and cosine functions are periodic and they have a period of 2p. All right. Now, that's for sine and cosine. Now, the other 4 trigonometric functions, they're also periodic, but we'll discuss that later. This section number, by the way, doesn't match the way I number it. That matches the section in the book. So if you go back into Canvas and look at the textbook, 4-6 is where you will find that in the textbook. All right? So, using the period to evaluate sine and cosine. Okay, so now what they want us to find is they want us to find the sine of 13 pi over 6 and the cosine of 13 pi over 6. Okay? Now, here's the deal. 13 pi over 6 is not on the unit circle. So how do we know what point we're dealing with? Well, we've got to see what 13 pi over 6 corresponds to, right? By trying to either add or subtract to get it back within that 2 pi interval, right? Okay, to try to get it back within that 2 pi interval. And so when we're looking at that, I need to break this down to where this equals to something in terms of 2 pi. All right, so if I were to take off to the side, let's say, if I were to take, let's see, and go 13 pi, let's see, let's do it, try to figure out a good place where I can do this. Let's do it over here. So if I go 13 pi over 6. So I'm trying to get this back down within 2 pi by subtracting off multiples of 2 pi. Now think about it like this. 13 pi over 6 is just a little bit over 2 pi, right? So if I were to subtract off 2 pi from this, and what would 2 pi be? 12 pi over 6, right? What would we be left with? Well, we would be left with 1 pi over 6. So that's the corresponding value, right, to 13 pi over 6. 13 pi over 6, okay, if you subtract 2 pi from it, you get pi over 6, right? So really, I can rewrite this as pi over 6 plus 2 pi. Okay? So in other words, we're trying to figure out what we can add 2 pi to get 13 pi over 6. It's pi over 6. All right? So again, when you've got something and you can kind of see where it is, it's just over 2 pi. I know by subtracting 2 pi, that would get me within a value on the unit circle. Okay, so your key is to take this and rewrite it, okay, in this form to where the value of t is somewhere between 0 and 2 pi. All right, so now that we've taken it to pi over 6 plus 2 pi, we know this is the value that we would use on the unit circle. So now let's take a look. So at pi over 6, the point is square root of 3 over 2, comma, 1/2. And then so the value of t that I'm going to use now is going to be pi over 6. And at pi over 6, the point that I'm going to use there, the corresponding point on the unit circle is square root of 3 over 2, comma, 1/2. So in other words, we've got to take this, rewrite it in this form, so we know that this is the value of t that I'm going to use to get this point on the unit circle. Now I can evaluate sine and cosine. So I want to know the sine of pi over 6. And remember, that's going to be equal to the y coordinate, right? Let's remember from the other one, the other lesson, sine of t is equal to y. So what's our y coordinate here? 1/2. And the cosine of pi over 6 is going to be the x-coordinate, which is square root of 3 over 2. So remember, this is always the sine, and this is always the value of cosine. All right, so we can get that pretty easily once we know what this value is and get this point. All right, so let's see if we can rewrite negative 7 pi over 2. See if we can rewrite negative 7 pi over 2 now. All right, so negative 7 pi over 2. So let's think about this. How are we going to get negative 7 pi over 2 into a range between 0 and 2 pi? Okay, so let's think about it. So when you look at this, 7 over 2, okay, so that's roughly negative, what, 3.5 pi, right? Isn't that right? Okay, because 2 times 3 makes 6, so that's negative 3.5 pi. And so if I'm at negative 3.5 pi, to get it between 0 and 2 pi, then I'm going to have to add 4 pi to that, right? So off to the side again. I need to go off to the side and do this. I need to go negative 7 pi over 2. And what did we say we needed to add? 4 pi to that. And once again, how did I get that? 7 over 2 is 3.5, right? 3.5 pi. It's at negative 3.5 pi. So what interval or what multiple of 2 pi do I need to add to get it between 0 and 2 pi? I've got to add 4 pi to that. So when I do, let's see what we get. Okay? And adding 4 pi, I'm going to go ahead and write that as 8 pi over 2. In order to make my denominators match, when I add that, that's going to be pi over 2. So now, since I've added a multiple of 2 pi to it, I know this value corresponds to this value. And so now I can rewrite this as pi over 2 minus 4 pi. Pi over 2 minus 4 pi equals negative 7 pi over 2, so I know that they're the same. So now what's my t value going to be? It's going to be pi over 2. Now that I know the right t value, then I can go back to my unit circle, and then I can come up with a corresponding point. So at pi over 2, the point is 0, 1. 0, 1. All right, so there's the corresponding point that I'm going to use to come up with sine. The sine of pi over 2 is going to be equal to the y value, which we know is 1, and the cosine of pi over 2 is going to be equal to the x value, which we know is 0. All right, so the whole key to this lesson is getting this number, all right, back to a value that's between 0 and 2 pi. In other words, how would you do it? And by adding or subtracting multiples of 2 pi to this number to get it back within the range of 0 and 2 pi. Once you discover what that number is by adding or subtracting the multiples, then you have your t that you're going to go into your unit circle to get the correct point, to get the right values of x and y to evaluate your sine and cosine functions. All right, so there you go.